So let me discuss why we need page replacement algorithm. So in order to discuss this, I have taken the following diagram. So in this diagram, I have hard disk, and inside this hard disk, I have a process called P, and this process P has been divided into 6 pages, right? So next, I have a RAM, and this RAM has been divided into totally 9 frames. Inside this RAM, as you see that frame 1, frame 5 and frame 8, I made it in red color. Why? Because process P, in order to complete its execution, it needs to use frame 1, frame 5 and frame 8 only. It cannot use any other frames. I repeat, process P, in order to complete its execution, it can use either frame 1, it can use either frame 5 or it can use either frame 8. It cannot use any other frames, right? Now, let us assume that CPU wants to execute the process called P. So in order to execute the process called P, it is requesting the page called 0, right? Since page 0 is not present inside the RAM, I need to move this page 0 from hard disk to RAM. So let me move this page 0 from hard disk to RAM, right? Now, CPU, after executing an instruction in page 0, it is requesting for the next page, that is page 1, right? Since page 1 is not present inside the RAM, I need to move this page 1 from hard disk to RAM. So let me move this page 1 inside the frame 5, right? Yeah. CPU, after executing an instruction inside the page 1, it is requesting for the next page, that is page number 2, right? So since page number 2 is not present inside the RAM, we need to move page number 2 from hard disk to RAM, right? So let me move page number 2 inside the frame number 8, right? Now, all the frames that has been allocated for process P has been occupied, right? Now, CPU is requesting for the next page, that is page number 3, in order to continue execution of process P, right? But since page 3 is not present inside the RAM, I need to move page 3 from hard disk to RAM, right? So if I move page 3 inside the RAM, in which frame I need to replace? In other words, which page number needs to be replaced by page 3? That is, page 0 needs to be replaced by page 3, or page 1 needs to be replaced by page 3, or page 2 needs to be replaced by page 3. So we can determine this by using page replacement algorithm. So this page replacement algorithms determine which page needs to be replaced by a new page, right? So we are studying the following page replacement algorithms, that is first in first out algorithm, optimal page algorithm and least recently used algorithm, right? Now, what is this page fault? When CPU is requesting for a particular page of a process, if that page is not present inside the RAM, we call that as a page fault. For example, CPU, in order to execute process P, it is requesting a page number called 4. But page number 4 is not present inside the RAM. We call this as a page fault, right? Next, what is page hit, right? So when CPU is requesting for a particular page of a process, if that page is present inside the RAM, we call that as a page hit. For example, CPU is requesting page 0 of process P. Since page 0 of process P is present inside the RAM, we call this as a page hit, right? I hope you understood this. Thanks for watching. Thank you.